Welcome to this video. Before we go to the ocean surface currents, uh, just give an example here. This is the Atlantic Ocean. This is the North Atlantic Gyre. This is the South Atlantic Gyre. There are North and South gyres in the Pacific as well. These gyres are very important because they turn around day and night. They turn around day and night, and they turn around nutrients. And for instance, eel travel with them, small eel, like 7 centimeters or something. They come out of the rivers, not only in Europe. They get into the ocean and they get swept up by this gyre. And since this gyre carries nutrients, they grow, and by the time they get here, that depends on the eel, they are much bigger, and by the time they come back, uh, they are adult and they climb into the rivers again. And that's certainly not only in Europe, that's across the whole world. So anyhow, together with the eels, you also the whales turn around, and the turtles turn around, and I think it's this one that is called the turtle current gyre. So I suppose there's much more turtles turning around here than in any of the other gyres. But turtles are turning around in all of the gyres, and certainly in this one that is called the turtle gyre. This one or this one, or both. I think it's this one. It's called the turtle gyre. So eel, turtle, whales, and what we will claim is that all migrations, the population of the world, also with at the end with modern humans, happens through these gyres. If these small animals and big animals can make use of it, why should humans not be able to use of it? Heyerdahl, which is a scientist, um, he used this gyre to get from Peru, from South America, to Polynesia. That's across the the Pacific Ocean. So that's big. That's big. And they did that with a raft, not with a ship that was uh, had a rudder. It was a steerless raft, and in roughly 100 days they got, by rafting on this current from Peru, South America, to Polynesia. So I suppose he arrived more or less here. Um, so next we go to this graph. This graph. I'll show it smaller first. That's the same graph. And it's the ice core measurements in Lake Vostok, Antarctica, so at the South Pole. The South Pole. So it's quite interesting. It's about the last 420,000 years, thousands of years, 420,000 years. So obviously we are here, but right now we are looking at the dust concentration. We see that the dust concentration is very low, and it was very high, uh, let's say during the ice ages. You can see here that at the end of this is the end of the ice age. the last ice age, and this is the actual interglacial we are in. And so you see that this was the former interglacial. It's not called Holocene. This actual interglacial is called Holocene. So you see that there's a temperature peak, enormous temperature peak, and it should be explained because obviously this is important. And then you have a steep fall of this temperature peak, steep fall, and then you have some fluctuations. And but the trend is going down in the glacials. The trend is going down in this glacial. The trend is going down. We're talking about temperature. The trend is going down. Every time the trend goes down, this is carbon dioxide. Uh, it's not our subject right now, but you see it's quite associated with temperature peaks. We're not even going to explain now or which one is the cause. That's not our subject now. What is of our interest right now is that in the depth of the glacials, ice ages, the depths, that we have peaks in dust, peak in dust, peak in dust. Show it here. Uh, Peak in ice age, peak in dust, peak in ice age, peak in dust, peak in ice age, peak in dust, peak in ice age, peak in dust. Antarctica. Um, okay, so uh, in our opinion, at the end of the ice ages that get cooler and cooler, uh, probably humans are able to live in the tropics, possibly in the subtropics, um, but certainly not in, let's say, most part of Europe and the northern part of Eurasia in general, and not the northern part of North America, because they are covered in thick ice that can be as thick as 3 kilometers. Um, so probably at this point you have 3 kilometers. So at the pole, at the South Pole, you have this much dust in this in the depth of this ice age. So we suppose that uh, the continents are very arid and well, very arid. That it's possibly also not ideal for the tropical forests. So as far as we know, in ice ages, tropical forests uh, retreat, withdraw in what is called forest refuges. The only forest refuge, the only continent with a large amount of forest refuge is South America. It's in the Amazon. It has 20 so much for forest refuges, and in Africa there should be three, only three. So the best place to survive, at least if you depend on forest or agroforest, because we claim that the Amazon forest is an agroforest, a man-influenced, enhanced agroforest. So the only place where you have a large amount of refuges is the Amazon. So you can more or less assume that it is the place where we humans survived during the ice ages. Because for a number of reasons we claim that humans are, as we are, existed at least 2 million years, at least 2 million years. Uh, and some others claim that we humans exist for at least 300, over 300,000 years, because there's the supposedly we found fossils of early modern humans in Jebel Irhoud in Morocco, uh, but we will claim there are much more fossils of around 2 million years that prove that humans already existed, but that's for other videos.